The drop rate seems consistent across all 12 rows.
Confirmed. Centimeter spacing is holding tight.
Được nhiên ở phây, như trong bé nên nhịp lại khi cốt đến đánh trả liên cái lần này cả. Tập gió nơi nào đã đến ngay nan cơ thể.
Here's another one with the wilt.
Okay, pulling it now.
Slow the conveyor speed. We have a backup on this side.
Copy that, adjusting the pace now. We're almost topped off back here. All right, tell them to slow the belt down. Heat's holding steady at 95. Looks good. We'll keep this pace for the next mile.
Still seeing too many clumps getting through. Noted. Let's adjust the vibration.
Keep it moving slowly. Align with the rails now. Okay, pull back. Straps are tight, Foreman.
Documents confirmed. You are cleared.
Barrier is up. Please proceed slowly.
Internal atmosphere reports nominal. Dew point stable.
Copy that. Release the next stage.
Scan complete for 34B.
Data verified against the log. Looks good.
All right, moving on.
Look at the vortex flow here.
The pressure differential seems optimal. Yes, the separation efficiency is excellent. Pressure holding steady at 20 psi. Good. Keep the flow consistent.
This one here shows signs of contamination. The color reading is off the chart.
Agreed. We need to isolate this batch immediately.
Utilizing advanced AI, the optical scanner deploys multicolor beams to inspect every kernel.
The weight is fluctuating right at the threshold, 4,500 tons.
Confirmed. The load cell readings are stable despite the resonance.
Descending through these clear polycarbonate tubes, the peanuts move in a dense, continuous ribbon toward pre-roasting, aided by anti-static illumination.
We need to reduce the temperature here. It's spiking.
Oh. Adjusting the dial now. Let's see if that stabilizes the cool down.
See the peak here. That indicates high fracturability.
Yes, much better than the previous sample.
The roaster's control module automatically adjusts temperature curves based on sensor feedback. Servo motors shifting position.
To halt the residual roasting process, the robotic agitation arm gently stirs the peanuts on the cooling belt, meticulously monitored by infrared sensors.
Efficiency is at 98%. The alignment rollers are performing perfectly. Good.
Let's keep an eye on the pneumatic pressure for the husk removal.
Here we see the byproduct recovery system in action. The rhythmic pulses ensure that every last skin is retrieved and moved.
A high-pressure refining mill compresses the peanut paste biased between steel rollers, producing a smooth,
Blend ratios confirmed on the screen. The crunchy bits are evenly distributed.
Yes, mesmerizing consistency achieved.
Look at the flow pattern here on the chart. It matches the movement in the tank.
Agreed. The agitator is maintaining the required consistency.
The peanut butter travels through these sealed stainless pipelines towards the fine filtration unit, ensuring a perfectly smooth consistency.
The high-precision filtration unit utilizes ultrasonic vibrators to separate oversized fragments.
The pressure consistency is excellent now, well within the target range.
Agreed. The uniformity looks perfect on this batch.
The speed is stable at 500 jars per minute.
Good, the alignment gates are holding steady.
The fill weight on lane 4 is dropping below tolerance.
The system caught it. Check the diversion count.
The jars move through the pressurized air cleaning tunnel. High-velocity jets spin dust particles away, revealed by the swirl.
Check the parameters on the main feed.
Looks well within tolerance. Moving to the filler.
RFID scanners track each pallet as it moves into designated storage aisles.